Alright, here we go. We are looking at BP8. So, a little bit different here. Let's go into this one. We'll save it. We'll do our save as. And we've got BP8 this time. And we will change our task description. Look at our pseudocode. BP8. So this one's a little bit different. We are going to turn a motor on when the bump switch is pressed, turns off when it's pressed again, and this goes forever. So that forever should tell me that I'm going to need a while loop. And then I'm going to be integrating some of the things that I just did with the bump switch is not pressed and pressed kind of stuff. So well, the bump switch is not pressed, it should just wait. And then when it's pressed, it kicks out of there and it starts the left motor. And then if you think about the condition of the bump switch, it is currently being pressed. Like if you go in slow motion, imagine that you're pressing the bump switch. Its value is now 1. So it needs to stay in a while loop while it's being pressed. And this is kind of the part that's a little bit tricky to understand. So now we want to say while it's being pressed, stay in this while loop. And then when you let go of the bump switch, now it should enter another while loop. While it's not being pressed. Then as soon as it's pressed, it kicks out of that while loop, stops the motor, and again, it's still being pressed. We're doing this in slow motion, so now we need to say while it's being pressed, wait in that, and then as soon as you release it, then it jumps out of there and begins back again. So this is kind of my thought process with that. Again, I'm going to look at the actual bump switch to kind of show you again what I'm talking about here. So when we look at that bump switch, its current condition is a 0. It's not pressed. When I press it, and again, if I do it in slow motion so that this is pressed, it's now a 1. The motor starts running, but then I don't want it to stop running until I release it, which then goes back to a 0. So it's now in that condition, looping, waiting for another press for it to stop. Then in order to restart, I don't want it to restart now on a 1. I need it to go back to a 0 and then restart on another 1. So I need to look, these are transitions going from 0s to 1s on that switch that I need to take it into account. So if you notice, this goes from a 0 to a 1 right here. So there's a 0 to 1 transition when I push the button and exit out of there. Then, after this, it goes from a 1 back to a 0. So it's currently being pressed, and then when you let go, it went from a 1 to a 0 to kick out of this loop. Now you're being not pressed. So now it needs to go from a 0 to a 1 in order for it to move on, and it stops the motor. And then it needs to go from a 1 back to a 0 in order to move on from that. So those are the kind of transitions that are being done in each of these while loops. So it's a lot of copy-paste, which is kind of nice for you. So I'm going to copy this, paste it, and I'm just going to paste this a few more times. So it's the same while loop, we're just going to change the value of things. So we're going to say while it's not being pressed, it's going to stay in that loop. Once it is, it kicks out of that loop, and now it starts the motor. So we can put a little note here that says waits. It's waiting until switch is pressed. That's essentially what that does. It waits in that loop until that switch is pressed. It's pressed, it kicks out of the loop, starts the motor. Now it's going to wait until switch is released. So it does that. And then once it's released, this is in the wrong spot, it's now going to wait for it to be pressed again. So this waits for another press, waits until released. So hopefully this is making a little bit of sense as to why we do this. Now we just have to change our numbers here. So this needs to be a wait for a release. So while it's being pressed, it sits in this loop, kicks out. Now we're in this loop waiting for it to be pressed again. So when it's pressed again, it kicks out, stops the motor. Now it's being pressed again. So it's in that press mode. It waits until we release it. When we release it, it goes back to the top waiting for another press to occur. So hopefully that makes sense. Now, what does all this need to be in? Well, if we want to continue forever, we need to now put all of this in a while loop that is forever. I'm going to put my open curly and my close curly and hit my fix formatting. And it's going to now have all of this in there. So let's give it a shot. Let's see if this works the way we want it to work. So we're going to have our motors, and we've got our sensors, but again, our sensors work. So the 1 and 0 works just fine. So I'm going to say when I'm going to click so we can kind of see what our motor does. So right now it's waiting in this, it's waiting to be pressed. So when I press the button, it's now waiting to be released. When I let go, it's now waiting to be pressed again, and now it's waiting to be released. And it starts over here where it's waiting to be pressed, released, pressed, released. Press to start, press to stop, press to start, press to stop. Now sometimes you're going to have issues because these switches aren't the greatest switches, and they have what's called bouncing that occurs. So when you are actually pushing that switch, there are metal contacts in there that are coming together that actually bounce. So they actually make contact and non-contact probably 3 or 4 times in a single press. So when you push this down, it's actually going press, release, press, release, press, release, press, and it holds. That's bouncing that occurs between the metal contacts inside of there. The higher quality switch you have, the less that occurs, but it pretty much happens to all switches. If you put this on an oscilloscope, which actually measures waveforms, you can see that bouncing occurring. And we want to eliminate that bouncing. So to eliminate it, we can either get nicer switches, but they're VEX switches. We can't really change that out. So we do some things in the software to fix that. And again, this we didn't see any problems. When we pressed it and released it, it did fine. But let's say that we don't want to start this motor right here. We don't want it to be started on the press, because when I have a start button, I usually don't want to start the motor on the press of the first click. I want to start the motor on the release of the first click. So I'm going to move this in my code to after the release. And the reason is because I want my hand to be moving away from the item that's starting to spin. So if it's a saw blade or a drill bit or whatever, I don't want my fingers to be near it on the start switch. I want to be releasing the button so my hand is on the way out of the system. So this will allow me to press it, and then as it's released, then it starts the motor. I could even put a wait time there so it waits a second before it starts the motor so I clear my hand. I'm not going to do that right yet. So let's try this. So this isn't going to start that motor until the release of the first contact. It's usually called a bump. So when you hear the word bump, that means that it's a press and release. So I press it, and then I release it, and now it starts. And then here I want to stop immediately when I press the switch, so it's going to stop on the press. It's waiting for the release. So again, it's waiting for that to release. Now I release it. Now it's waiting for a new press. It's waiting for the release of that press. Starts the motor. Now it's waiting for the press. It'll stop it immediately. Now it waits for the release of the press. This switch is actually doing pretty well. Some switches are really bad on their bouncing, and you need to add a little bit of a wait time so it has a second for that bounce to basically be negated. It allows the sensor to not, essentially you see the first contact of the bounce and then the very last contact, and you skip all the intermediate stuff. So imagine me clapping my hands, and you hear the first clap and then close your eyes, and I clap 10 more times, and then I have my hands together for the last one, and then you open your eyes. So you initially saw that I pressed, and then when you open it a little bit later, you still see my hands together, and you miss the whole open, close, open, close, open, close, open, close, that bouncing part in the middle. So essentially we can do that by adding a few more wait times in here. We could do a wait, and we could do like a 50 millisecond wait in between. And again, it's such a short amount of time for the human being, but for the computer, I mean, that's a long amount of time to wait. But essentially it makes it so the sensor doesn't recognize or doesn't look at those open and close transitions and bouncing. So you might need this in your code after you do these while loops, because again, as soon as you release, or as soon as you press the switch and it kicks out of this while loop, it's releasing, pressing, releasing, pressing, releasing many times over the next few milliseconds. So that wait just kind of lets us skip over that. Now Robot C actually does this. They have commands, which I'm not teaching you because I don't like them. They're these until commands. So there's like an until touch command that exists that people at Robot C made. But if you go to the definition of that, you'll notice that it's just a while loop. And if you notice, they have a wait in milliseconds. This is there so that you basically don't hog the processor. So it gives it a little bit of millisecond wait time, which is what we did here. We did 10 milliseconds. They did 1. But if we go down to until release, that's waiting for a release of the sensor. But then until bump. So look at this until bump. This is a press and release. So here's a while loop. It's waiting for the sensor to not be 1. So it's waiting here while it's not pressed. So while it's not pressed, it sits here and cycles here. And then when you push it, it clicks out. But then if you notice, you see this wait in milliseconds for this delay time that you put in. So this defaults at 10 milliseconds for a delay time. This is to eliminate bouncing. This is a debouncing part of the program that they've added into here. And then you have another while the sensor is pressed, it sits in this loop. So it's waiting for a press, which gets it out of this while, and then a release to get it out of this while, and that's what a bump is. So it's waiting for that switch to be bumped, which is a press and release. So I just wanted to show you that even the programmers of this of Robot C see that you need to have a debouncing in there. 50 seconds might be a little much. 10 seconds would probably be fine for what we're doing. But again, if some switches are really bad, bumping it up to 50 isn't that big a deal. And it works just fine. I want to show you that. I'm going to copy and paste this 2 more times. I'm going to copy it here. And I'm going to copy it right here. And I'm going to download and run this so you can see where are my errors. Oh, I didn't, yeah. Sorry, I didn't want that in there. That was just to show you. All right. So these are just for debouncing purposes. I want to show you it really has no effect on the code from a you hearing it standpoint or seeing what goes on. So here's a press, here's a release, here's a press, stops immediately, here's a release. Press, release, press, release, press, release, press, release, press, release, starts it, press, stops it, release it, moves it on. Press doesn't start it, it waits for the release, press stops, release. So again, those things you might have to add for debouncing purposes. You can put that in your comments if that's what that's for. Again, hope that helps. Have a good day.